How scientists classify matter. And the first thing we're going to talk about is like what is matter. And matter is anything that has mass and takes up space. So most things are matter. Energy is not matter. Light is not matter because it's a form of energy, but most things are matter. So basically, how can we organize those? The first major breakdown that we deal with is pure substances and mixtures. Pure substances are going to be always the same. They're going to look the same throughout. They're going to be the same throughout, and they're only going to be made of one kind of matter. You cannot separate them easily just by physical means. You can't just sit there and pick them apart, and that's because they are chemically bound to each other or chemically bonded. When we say that they are the same throughout, that means that they're homogeneous, and you can't, they're always going to be that way. So you're not going to ever find clumpy, pure substances. Like, they're going to be uniform throughout. Mixtures are the other major type, and this is just when you take at least two pure substances and you mix them together. They're not chemically bonded to each other, so that each matter does contain its own properties. So this would be an example, a really easy example would be trail mix. So trail mix is a mixture, and each individual thing, the raisins and the nuts and the granola and whatever else you put in there, it retains its own properties. Like, I can pick up a piece of granola and it doesn't affect the peanuts or anything. Mixtures can be separated by physical means, which means that you can take them apart and turn them into pure substances. So just a couple examples of that would be a filtration, where you're separating solids from liquids. Distillation, where you are separating based on different boiling points. And chromatography, where you're separating different, basically on different solubilities of things. So just for an example down here, you can pause the video and you can take a moment and just kind of organize these guys into either pure substances or mixtures, and then you can restart it and I'll be moving them. So we're hoping uranium usitmi is a pure substance. Lead from a pencil should be a pure substance because it's graphite. Chunk of gold should be a pure substance. Nuts and bolts would be a mixture. Good old Lucky Charms would be a mixture. Pepperoni pizza would definitely be a mixture. And then the one that it always ends up to is air. And air is a mixture. It's a tricky mixture, though, because it's not one that you can easily see the different partitions in. Alright, in this next slide, don't freak out, because this top part we already talked about, but now what we're going to do is just go across breaking them down even further. So pure substances can be broken down even further into elements and compounds. Elements are the simplest and easiest ones to know, because if it's an element, it's on the periodic table. You cannot separate it any simpler than it already is. If you do anything else to it, it would be a nuclear change. And elements are made up of atoms. Sometimes the elements form molecules, but the elements are atoms. So there's a couple examples here. So we have silver, we have oxygen, we have hydrogen, but realistically, if it's on the periodic table, it's an element. The next type of pure substances we have are compounds, and this is when elements are joined together through chemical bonds, and these can form molecules or crystals. It is important to note that it is different properties than just the elements themselves, and this goes back to like when I talked about how we made salt with the really dangerous metal and with the really dangerous chlorine gas. So when we put them all together, we made a compound that was different from the elements. It is important to note that you can take the compounds and you can do a chemical change and turn it back into the elements. So you can make the compounds and you can break the compounds for the pure substances. On the mixture side, we have two distinct types. We have the homogeneous mixtures and the heterogeneous mixtures. Heterogeneous mixtures are kind of the easiest ones because they're very distinct. You can see them with the naked eye. Sometimes you might need a microscope, but you can clearly see the different regions. So Italian salad dressing has like the different stuff in it, a chocolate chip cookie, a brick wall. The mixture that you're going to use in lab is a heterogeneous mixture. You will be able to see the different chunks, and then what you're going to do is you're going to separate them out. Homogeneous or homogeneous mixtures are a little trickier because they are a mixture, but they're not something that you can see because it's only on the molecular level, and we don't see at the molecular level. So the example would be salt water. Don't just write salt, it's salt water. So the salt disperses throughout the water, and unless you can get down on the level of the atoms, you don't see it. Air is an example of a homogeneous mixture. It has lots of different things. And we have nitrogen, oxygen, that kind of stuff. And if it's a homogeneous mixture, it's also known as a solution. And you may want to write down, it can be solid, brass. Solid ones are called alloys. Oops, not what I wanted to do, sorry. So this one can also be, if it's a solid solution, it's also called alloys, which are typically metal ones. And then this last thing down at the bottom here, it refers specifically to compounds, and it's called the law of definite composition. And it sounds pretty simple, because it is, but this is something they came up with when they were first studying chemistry, which was pretty big. Is what they said is that if you have a compound, and it is a true compound, you're always going to have the same elements in the same ratios. And the simplest one way of saying that is if I have water, I always have 2 hydrogens bonded to 1 oxygen. If I don't have that, then it's not going to be considered water. And then the last slide in this video, we're going back into your normal packet, and we're going to like right where after it says that. So we're at the very bottom of page 7. So at the very bottom here, there's just 3 sentences, just a couple different things here. Make sure you want to know the differences between the pure substances and mixtures, and you want to definitely know that if you're a pure substance, you're always going to have the same characteristic properties. So one of the good things about mixtures is that you can change the properties. So if you look at this explanation right here, one of the big draws of coffee is that you can get it to be any way you want. But for example, gold, it's always going to be the same. It's always going to have the same melting point. It's always going to have the same hardness, that kind of stuff, if it's a pure substance. Number 2, every pure substance has the exact same composition. So again, if you're water, that's a pure substance. It has to be made up of that same structure with the same elements, or you're not considered a pure substance. And number 3, a pure substance cannot be separated without changing its identity and properties. So you cannot separate water without changing how it's going to act, because as you know, hydrogen and oxygen gas act very differently than water. So this is video 10.